Hi students, I have something to explain on how to checking your coding style, code quality using using your NeoESPA. Okay, so let's jump to NeoESPA first. So let me switch to the screen to NeoESPA. I'd just like to mimic you when you submit your code using the first problem, which is the simplest one, difference of squares. So if you select a file, in my case, I just intentionally change some of the styles, to check it, to be checked by the style. So once you get 100 points from your NeoESPA, this link is enabled, okay? So just click this link and then, so please be patient and try this once you get a full point specified in your lecture note. Okay, so you have seen there's some of the issues here. So the first issue may be enlarged like this, and second issue may be enlarged like this, and third issue may be enlarged like this. But in some cases, you don't know what is the exact reason for the issues, even if it is briefly described here. So if you are not sure why this is issued, so just click ... at the end, okay? So you can push this one, okay? Then the details of that issue is explained at the beneath of the screen, beneath of that window. So files should contain an empty new line at the end. Okay, so there's no empty line, but even if it is shown here, so maybe it is related to this issue. Okay, so this issue may be clicked here, makes the line endings LF and CRLF, but this is much like a bug of the system, because you are using the Windows system, and in Windows system, you are using the carriage return and line feed ending. Okay, but in NeoESPA, it is built up on the Linux system. So it is using just line feed at the line ending. Okay, so this issue may be related to that issue. So let me show you, and let's take a look of the second one here. Wrong number of spaces around an operator, bracket, operator bracket, comma, before block opener. So in this case, maybe this assignment may be the problem. So the Python is regarding that is an operator, but you need spaces just before and at the end, before and after that operator. So let me switch it to your PC screen. This one is the source code. Okay. Can you see this source code? It is same to that that problem. So I'd like to just copy of them. Okay. And if you just add some spaces around the assignment operator, and for the first issue, you may want to add a blank line at the end. Okay. Then I'd like to resubmit this. But one issue just removed, and this trailing white spaces. So it is a different issue. Okay, so that may be related to this problem. So as you know, it is automatically indented up to here. As you know, there's some spaces here. So that is the problem. So let me just erase this. Okay, so your cursor is moved up to here. So let me save this again. So can you see this dot here? It means that it is not saved. So if you want to save it, it disappeared. And I'd like to resubmit this in your NeoSPAM. Perfect. Okay, can you see? So just remember that when you have an issue, just click some part of it, and the details for that, just click ... at the end of each issue. Okay. Then let me switch it to your new screen for today's lecture note. Okay. So today's problem is somewhat related to the higher the functions, but you know that in order to use functional styles, you have to focus on the values, okay, not the operations. So if you are focusing on the operations, procedures, that is called a procedural programming. In other terms, it may be considered as imperative programming. Imperative means you are focusing on every instructions, step-by-step instructions. But now you are focusing on the values. So you may even consider the steps, but every step should produce some kind of values, okay? So some list operations return the list. Most of all, the list constructor list itself is returning some value. But for an example, the function sorted returns a list, but the method sort does not. Okay, it is a method just altering the status of an object, list object. So let's compare them from your Visual Studio Code. Okay, so in your Visual Studio Code, you can make a new terminal. Okay. Let's just close this a little bit. And in the terminal window, you may invoke a Python interpreter. Okay. You know that list of something, Python is making a list. So you can store it into a character list. So list of Python is storing a list. So the value of CS can be printed like this. But if you want to store another list, maybe DS, you may try that from list, you'd like to sort. But it does not produce anything. It produces nothing because the sort method does not return something. But as a side effect, CS is changing. Okay. So let's take another example. But if you want to, what is good name? ES. So I'm not so creative about the naming. Okay, so sorry for that. If you make another list, ES, it is not sorted list. But if you store it into DS, but in this case, you'd like to make it sorted. Okay, sorted means it will generate a sorted list from ES. Okay, so it is a function. It is a function. So just type DS. In this case, it is stored. Okay, can you see the difference of sort method and sorted list, sorted function? So the method just altering the status of the value of CS, but doesn't returning anything. But sorted is returning something, okay, returning something. So that is the main difference of the method and the operator or function. So let me show you another example. So in your lecture note, as another example, the operation plus. What is this the result of plus? It is a concatenation. Okay, it is a concatenation. But there's another concatenation method, extend. So let me just tell the difference. What is the difference of plus and extend? So you know that CS is a sorted list and ES is not sorted list. And you may want to append them, CS plus ES. So it returns a list. So you may store this as FS, CS plus ES, maybe stored here. So this is a long list, okay? This is the effect of concatenation. But if you apply something just like that, CS extend, and another thing is that CS is not changing, ES is not changing, but FS is created. But if you want to apply extend, CS extend ES, then CS is changing. But if you store it into FS, CS extend ES, you may expect that extended list may be returned from this method. But it doesn't return anything. But CS is changing. So can you see the difference? Method is changing the status of that object before the dot, but it doesn't return anything. So let's just take a look of your lecture note. So which one is better for functional programming? So in functional programming, the formal examples are more convenient. I mean that rather than sort method, sorted is more convenient in functional programming. And rather than extend, plus concatenation operator is more convenient in functional programming because functional programming focuses on the values. So it is focusing on the producing some values, and it is expecting that some operation is returning new value from its argument. So I said before that it may be inefficient in some cases, but it is more readable. Your new value is created. So let's take a look of another power of functional programming using a simple setting. So you are focusing on, if you want to make a new file, the new file name is search9 that time. So you want to make a search of 9 from a list. Okay, so you may make a list NS. Okay, so NS is 1 9 1 0 8 2 9. So you may print it. You may print NS, but I want to searching for the index of them for the target. What is the target? The target is 9. So you can easily compute that index is just 1 since it can be located in the second place here, and third place, fourth. So the last one should be returned. So let's take a look of locations. So locations is empty at the beginning, but you may try that. How can I search for that? If n, for n in NS, you'd like to searching for that if n equals to target. You'd like to append locations of them. Okay, so locations. So you may append the locations of n, but it does not append the locations of it. So just print locs here, locations here. So you may try that, but as you know, this is absolutely buggy code. Let's execute this again. Okay, so there's no problem for this 32-bit version. Okay, so you want to searching for the locations, but not locations is added. Okay, so that is natural because you are adding n rather than the location. So in order to get the location, you may have an index I starting from 0, and the index may be incremented every time, and you want to add I here. So running this again, save this, and running this again. Okay, so the locations 1 and 6 is added correctly. But this is much like an imperative style. So isn't it good to produce the pair of some index and the value of them? You can do that. Rather than ns, you just enumerate ns. So it will return pairs of them. So let's just add n here. So n is not a good name because this is a pair of index and index and the value. So let's just pairing it as p. Okay, so if p1 is a target, then append p here. So let's take a look what's going on with the enumerate. Okay, so let's just enlarge this. We're showing the whole code. So can you see? The second component is the value of n, and the first component is the index. So you can safely add index here, p0. Then you may do the similar result, but in this case, you are just adding the index of 9, okay? But this is not still functional style. In functional style, you may use that index and n is natural way to represent the pair. And then you can compare n, which is the second component, and you can add the index as your first component. So this is a functional style. So let me do that. So another functional style is that if you really want to collect that I, then maybe represented as a list comprehension. So rather than this, just producing the list comprehension, and this condition should be described as a filter here. So your code is getting simpler. So this is a functional style. All the controls is hidden in the restrictions of generator and restrictions of a predicate. Can you see the power of functional style? Not yet. Anyway, so that is the issue of today. So you are handling the functional style with functionals. So this is much like finding this is returning, but this is not still functional style. In functional styles, it is just a one-liner. Okay, and zip function zip function is very similar to enumerate, but it makes pairs of arbitrary two lists. Okay, so let me show you what is the zip performs. Okay, so you're using your terminal in Python. So you have made enumerate. So you may have a string, my string s1 is Python. Then you may expect that enumerate is the pairs. Okay, so you may expect that enumerate of s1 will return the pairs, but it is not really. It is an enumerate object rather than the list. Okay, so actually it is a generator. So if you want to get a list perspective, you make a list generator, so list constructor from the PS. So it will really return the enumerated version. So you can do it directly from enumerate, list, enumerate of S1, and PS is much like that. So this is simple. So let's maximize this panel. But zip is very similar to that. So if you really want to get the index started from 1, not started from 0, how can you do that? You have an idea. Your idea may be related to the range. Okay, so you may want to make a list of range up to here, but this is not the list. So you can make it from list range of length s1 plus this. It is not ended. Okay, so list is generated, but it should start from 1. So you may make a list of range starting from 1 to length s1 plus 1. This is more good than range list. What's wrong? Length. Okay, this is a problem. Okay, so length rather than length. List of this one. Okay, so it is starting from 1. So you may make an indices of them. IS, you are storing the IS maybe another indices. Okay, indices may be stored. List of range 1 starting from 1, length of s1 plus 1, and you can make a list of indices. So indices is like this, and you can make a zip with it, zip with indices with the string 1. But this is a zip object. Okay, so let's make another pairs QS with zip with list. So let's make this. Okay, QS list of zip. Okay, and QS may be a pairs, which is very similar to enumerate, but it is starting from 1. So it is maybe RS, maybe it can be applied in arbitrary sequence. Okay, so you can make a list of zip with Python and indices, and the order of the pair is just switched up. So in using enumerate, the first component is always an index starting from 0, but zip is more powerful. You can make pairs of them with arbitrary list. Even RS, SS maybe strings of strings, zip with, you are concerning of Python, but in some cases, you don't know this kind of a language. Haskell is another language, okay? But beware that the length of them is quite different, okay? So the length of Python is 6, but length of Haskell is 7. So zip can be possible to pairing of N and L, but the last L is dropped. So SS pairs of n, you know that the last L in Haskell is dropped because it is long. There's no pair in other component, other sequence. Okay. So with this setting, you may get enumerate of Haskell much like this. Okay. So another QS, RS, SS, TS. Okay. TS maybe. So forgive me for the uncreative one. So list of zip of Haskell, but your range is starting from 1 up to arbitrary number, which is more bigger number than Haskell. Okay, that is enough. Okay, so you are pairing with zip, and this is a list. Okay, TS. So you can get the length of Haskell is 7. Got it? Okay, good. But you may use higher functions. You may use higher functions. If you want to getting indices from this list, you may define second function. It is accepting a pair and just return the second component of the pair, which is 1. So you may try map to the list. So you may try map of a second. Okay, map second to TS. It will return map object. But if you really want to a list from map of a second TS, then it is a list of this. Okay, so it is extracting the second component of TS. But should I make a first of P for return P0, which is very simple function. Okay, in order to get a list of characters from Haskell. So you may apply first from TS. So it is tedious enough. So in that case, you may want to characters, okay, but you may want to map, but lambda function. Lambda is accepting some pair and returning the first component of the pair. And this function is applied to, instead of the first, to TS, which is the same result of the previous version of first. So just type. Okay, so you are using the functional value rather than the first. Okay, so let's make it disable this. So if you want to map this rather than first, okay, lambda or P, and you are getting the first value of this, and you are applying this function to TS, it will return this. The same thing can be applied list map lambda from pair. We are extracting the second value of it from TS. So the map itself is receiving some functions. You can see that that function may be defined, or that function may be built on the fly, like this. So you can define first. You can define first using lambda. Okay, so you know that this is an error because first is disabled now. But you can see that you may do this using this one. So you know that this part corresponds to function. So you can safely store it. You can safely store it as a variable lambda P and returning P0. Then you may apply map first, which is a functional value from TS to TS. And you can also apply a filter. Okay, you can also apply filter. In some cases, you may be wondering about some of the values of maybe the second values of them. You may make a zip. Okay, you may make a zip of them from pairs. You want to make a zip of them of that list with subzip with the CS. Can I see the CS here? Okay, CS. Okay, so you can make a zip of pairs. Subzip with first one is extracted from CS, and second component maybe ordinal number, getting ordinal number from CS. So you can safely map lambda for each character you'd like to returning ordinal number C. And this lambda function is applied to CS. And then this will make a list and pairs. So you can see that second component is the pairs of them, which is returned from ordinal number. And you can extract the second pairs from them using the second lambda function. Okay, so you can get it. So not get, okay, you can get it from map. Okay, seconds maybe, or these ordinal numbers may be extracted from this list. Okay, so list of map of lambda or pairs, second component of it, to pairs. So this is the result of map list. Okay, so sorry, too many parentheses. So ORs is just extracting the second components. So you want to apply summation of them, but in some cases you may want another thing. So rather than summation of them, you may want to multiply them. In order to do that, you want to import functors. So once you import functors, you can use reduce in functors. Functors that reduce. Okay. But if you want to reduce the length of the name, you can import it from functors import reduce. Then you can just use reduce as a name. Sorry, help, not help. Help reduce. So what reduce does is that much like sum, what was ORs, like this. Okay, you can do that with reduce. So reduce with the plus operator, you'd like to get it two numbers, x and y, and x plus y, ORs. This is essentially same. Okay, you are applying the plus operator for every pairs in between of ORs. Okay, so you are applying plus to here, to here, to here, to here, to there, at the end, to the end. Okay, so rather than, why should I use reduce instead of sum? In this case, you don't have to, but in some other cases, you may want reduce. Okay, so let's assume that you want to product, you want to multiply every numbers of these ORs. There's no function like that, but you can make it using reduce. Lambda xy, x times y is just do that, all the numbers. Multiplication of all the numbers. So the factorial, do you know factorial? 10 factorial? You want to do that 10 factorial, this is not possible, okay? But you can do that very simply. Reduce from lambda xy x times y, but it's starting from range from 10 to 11. Okay, so it will generate from 1 to 10. Okay, so you've applied times operator. So this is just 10 factorial. Do you want 20 factorial? So let's assign in 20 here. So let's reduce 1 to n plus 1. Okay, and it's 20. 20 factorial. So if you really want to make it as a function, you can do that reduce as a one-liner. Okay, so 30 factorial like this. So once you get used to this functional style, your program is getting more simpler. So let's make this as one-liner. Okay, so in your old function, so you can do the old style, new style name equals name here. Then you may indent those parts. Okay, so you may indent those parts, and you can get the result. Okay, but if you want to find the indices, you can define it. Find indices. Okay, of ns from target. Okay, and you know that is the value of this. Okay, so this is the value of that. Okay, so you can safely return this value. Okay, so find indices from ns in target. Okay, same as before. Okay, compare this code with the lecture note. Okay, isn't it too complex? But you made it with just as a one line of list comprehension, which is very powerful. And the power of the list comprehension comes from the functional style. And you can use functional style using higher the functions. So yet more abstract version, okay? So you can make it. Any questions up to here? So if you have any question on the higher the functions, please review your lecture, video lecture on higher the functions. So today's problem is just very simple. Polynomial multiplication. Think of that you are given two polynomials. First one is x squared minus 4x plus 6. And gx may be interpreted 2x cubed plus x. Adding two polynomials, it is very simple. So this is the highest term. So 2x cubed plus 1x squared minus 3x, because you have to add this term with this term. Okay, 3x plus 6. Okay, so addition is very simple, but this is too simple, so you may multiply them. So the multiplication may be somewhat complex. You have to multiply this term with this term, multiply this term with this term, this term with this term, and this term with this term. So 6 terms should be obtained, and you have to sort them within order, and you have to sum up them same terms. So given two polynomials, compute the multiplication result of them. The coefficients of the polynomial an minus 1, a1, a0 can be given as input. Note that you have to consider the coefficients, okay, though they are 0. For instance, the polynomial of gx have 4 coefficients, 2, 0, 0, 0. So if you want to multiply them, 1, which is the coefficient of the first component, first term, minus 4 is the coefficient of the second term, okay, because you can consider this as plus minus x, okay? And 6 is the last term, and this polynomial is given as the second gx. 2 comes from cube, and 0 comes, there's no square here, and 1 comes from this x, okay? And there's no constant term, so it should be 0. And your output should be 2 minus 8, 13, minus 4, 6, and there's no single digit at the last, so it should be 0, okay? So please do this. It is very simple once you understand the polynomial. But if you want to, so please try that first. Okay, imperative version first. So once you get it, you will try the bonus points to use higher functions, at least one higher function in functional style. So once you get to this part, you may try to reduce style issues. If you don't have any question, then please thank you for joining today's lecture, and see you